Alright, so for part two, we left off, we were talking about intake of water and water of metabolism. That sounds strange, but when we break down food, we actually produce water as part of that. And that makes up 10% of our intake of water. I'm going to jump to this document real quick. And alright, so what we're looking at right here, this is a really simplified version of the formula for cellular respiration. And what that means, this first part right here is glucose. So the glucose that's in the food that we eat, we take that and we have to breathe in oxygen. And when we break that down, we produce carbon dioxide and water in addition to the energy that we make by digesting our food. Alright, so this is just kind of showing us that when we break down food, when we go through cellular respiration, we are going to make water as part of that. So that's where a little bit of our water intake comes from. Alright, as far as the output of water, the main way that we're going to lose water is through urine. And that pretty much equals the amount of water that we take in through beverages. So that's a pretty good way to make sure that your kidneys are functioning, is that if you're taking in as much water as you are letting out in urine. So that 60% of our output of water is urine. It says water lost through skin and lungs. Now, water lost through skin, this isn't talking about a sweating. We're going to count that different. But just throughout the day, you lose some moisture through your skin. And over time, that can add up. Through your lungs, if you think about this, if you've ever breathed into a mirror or into a piece of glass and it fogs up the glass, that's water vapor that's coming out of your breath when you breathe out. Now that's not a ton every time you breathe, but think about how many times you breathe a day. That's a ton of water over time. So we lose a decent amount through skin and lungs. We lose about 6% of our daily water through feces. So our large intestine is supposed to reabsorb as much of that water as possible, but we don't get all of it. So about 150 milliliters of water are lost through feces. And then lastly, water lost through sweat is about 6% or 150 milliliters. Again, these are averages. If you're exercising, you're going to be sweating a lot more, but you're also going to be drinking more and putting more water in, so that should balance out. All right, so we've covered most of this, just kind of like a quick review. Regulation of intake of water, so this is where all the water comes from. All right, where it says regulation, though, let's look at this table. So this is how we make sure that we're taking in enough water. If your body loses, it says just as little as 1% of its water, that's going to cause a change in our osmotic pressure. We've got a lot of dissolved substances inside of our body fluid, but if we lose that water, then those are going to become more concentrated. Think about if you had like a gallon of Kool-Aid and you pulled some of the water out of it, everything else is going to get a lot stronger and a lot more concentrated. So that's the same idea with our body. We're losing water and everything becomes more concentrated. So there's going to be an increase in the osmotic pressure of extracellular fluid due to water loss, and that stimulates osmoreceptors in the thirst center. So that means that our fluid becomes more concentrated, and we're going to have receptors that are going to recognize that. Okay, when it talks about the thirst center, that is going to be found in your hypothalamus. So hypothalamus, that's the part of your brain that controlled a lot of the hormones we talked about. So activity in the hypothalamus causes a person to feel thirsty and to seek water. So your brain actually makes you feel thirsty when you lose water. Drinking and the resulting distension or stretching of the stomach by water stimulates nerve impulses that inhibit the thirst center. So that means your brain makes you thirsty, you drink water, and when your stomach swells up with the water that you just drank, you're not going to be thirsty anymore. Water is then absorbed through the walls of the stomach and the small intestine, and the osmotic pressure of extracellular fluid returns to normal. Whenever you see it in a table like that, it makes it look intimidating. Basically, all that said was you lose water, you get thirsty, you drink water, and you're not thirsty anymore. So don't overcomplicate it, but I would know some details in there, that we have what are called osmoreceptors that recognize the change in the water concentration in our body, and the thirst center, which is in the hypothalamus, makes us thirsty. All right? We drink water, and when our stomach distends or when it swells or stretches, that inhibits the thirst center. All right, now we've got regulation of output of water. And again, these are just averages, but we went over these early. This is how our water exits our body. All right, so let's look down at the bottom. This is showing ways that we can regulate our water output depending on if we have enough water or if we don't have enough water. So first, we're going to look at dehydration on the bottom left. It says extracellular fluid becomes osmotically more concentrated. So this goes along with what we just did on the last slide. We're losing water. So our water becomes more concentrated. Osmoreceptors in the hypothalamus are stimulated by the increased osmotic pressure of body fluid. So far it's the exact same thing. Another thing that's going to happen, though, it says the hypothalamus signals the posterior pituitary gland to release antidiuretic hormone. We talked about that in the last chapter with our kidneys. So posterior pituitary releases antidiuretic hormone. The antidiuretic hormone is going to go through our blood to our kidneys, and remember what it does there. Antidiuretic hormone causes the distal convoluted tubules and the collecting ducts to increase water reabsorption. That's where we said that usually those parts of our tubules are waterproof. They're going to hold water, and that water is going to leave through as urine. But if you're dehydrated, you don't want to lose water as urine. You want to keep all the water that you can. So antidiuretic hormone causes those tubules and collecting ducts to let the water go back into the tissue, and we're going to reabsorb it into our blood so that we can hang on to more water. So when we do that, urine output decreases and further water loss is minimized. So if you're dehydrating, you don't want to be urinating a lot because that would make your dehydration even worse. All right, excessive water intake. Let's say we're drinking too much water, and that could be a problem too if we don't get rid of that extra water. It would dilute everything. So extracellular fluid becomes osmotically less concentrated, so everything's more watered down inside of our body fluid. This stimulates osmoreceptors in the hypothalamus. We decrease antidiuretic hormone. That means that the tubules are going to decrease water reabsorption. They're going to become waterproof again. They're going to hold the water on the inside, and that means that the fluid that we filter through our kidneys is going to leave, and we're going to urinate more often. Again, don't lose the big picture. All this is saying is if you're dehydrating, you don't urinate as often. If you are drinking a lot of water, you're going to urinate more often. All we've got to do is add the details as far as antidiuretic hormone and what that does as far as water reabsorption. All right, next up is electrolyte balance. So electrolytes, it gives us a quick definition. Those are substances that dissolve into ions. So these are things that when we put them in water, they dissolve. And an ion is a charged particle. So these are going to dissolve and they are going to become charged particles. All right. The major electrolytes that we're going to look at in this chapter are sodium, potassium, calcium, magnesium, and chloride. So first off, just know that those are the major electrolytes: sodium, potassium, calcium, magnesium, and chloride. Most of those we mentioned earlier when we were talking about the intracellular fluid and extracellular fluid. These are important because they help regulate things like hydration, our body pH, and things like nerve and muscle function. So we have to have those for those functions. We're going to look at a few specifically and talk about what they do in more detail. But as far as electrolytes go, it says the electrolytes gained should equal the electrolytes that are lost. So there needs to be a balance of those. If you are sweating, let's say you're doing a long run or something like that and you're sweating a lot, you're going to be losing a lot of sodium in the salt, in the sweat that you're sweating out. All right, so that's why things like Gatorade have electrolytes that are inside of them, because it's to replace the electrolytes that your body loses. Now, honestly, Gatorade, if you're just kind of mowing the lawn or something like that, you're not going to lose that many electrolytes, so you really don't need all of that. A lot of people drink Gatorade because they think it's a healthier option. It's really just sugary water. And if you're doing like some really hard endurance sports, that's what you need. You need sugar and you need to replace the electrolytes. But other than that, it's basically like drinking a Coke. All right, so that's why we have to take those in if we're losing them. So this chart, there's a lot of charts in this chapter, and it does a really good job explaining if you read the textbook, it explains what those paragraphs are talking about. So we can take these electrolytes in through our foods, through fluids that we drink, and through metabolic reactions. A lot of times when our body breaks things down, a lot of these are going to be released into our body fluid. So those are ways that we can take in electrolytes into our body. All right, so if we're adding extra electrolytes, more than our body needs, we've got to get rid of them because, like we just said, the electrolytes gained needs to equal the electrolytes that we lose. So we can lose electrolytes through perspiration, so sweating. We can lose electrolytes through feces and urine as well. So those are ways that our body has of getting rid of those extra electrolytes that we don't need. So let's look at a couple examples of those. And this one, again, it should be similar. This has a lot to do with the renin-angiotensin system that we talked about in the last chapter. So let's look at potassium and sodium and how that balance stays the same. Potassium and sodium, they're really important in nerve conduction. So we need to have these for your nervous system to be able to function. But there needs to be a balance between those two. Sodium and potassium need to stay at roughly the same levels. So what happens is as our potassium ions increase, so we're getting too much potassium inside of our body, that's going to signal our adrenal cortex. The adrenal cortex is going to release aldosterone. Again, this is kind of like the really quick version. Go back to chapter 21 and look at all of the steps in the renin-angiotensin system as far as how aldosterone is released. But we're just kind of jumping to the end part. So potassium goes up, aldosterone is secreted. That's going to make the renal tubules increase reabsorption of sodium ions. And whenever we take in sodium, we have to dump out potassium to keep that balance. We talked about that towards the end of the urinary system. So when sodium is reabsorbed, and that happened in tubular reabsorption, potassium has to be secreted to maintain the electrolyte balance. So if we're kind of going the long way around it, but if we've got too much potassium, we can reabsorb more sodium, and that's going to allow us to pump out the extra potassium that we don't need, because when we take in more sodium, then potassium is secreted. So that means that sodium ions are conserved and potassium ions are excreted. So that's the balance between those two. All right, let's look at calcium balance, and hopefully this should look familiar too, because we did this a lot in it was in the endocrine system. So we're looking at what happens if we don't have enough calcium. How do we keep that electrolyte stable? So calcium ion concentrations decrease. So our blood calcium is going down. When your blood calcium is too low, parathyroid hormone is going to be stimulated. So your parathyroid glands release parathyroid hormone. All right, so parathyroid hormone is secreted, and that's going to have a couple different functions. So let's start over here. Parathyroid hormone causes your intestines to reabsorb, or not to reabsorb, but it causes your intestines to absorb more calcium from the food that you eat. So right off the bat, we don't have enough calcium. Parathyroid hormone tells our intestines to absorb more calcium, and that helps pull the calcium levels back up towards normal. The next thing we do, parathyroid hormone stimulates osteoclast. All right, if you wanted to write this, because I know it's been a little while since we've mentioned it, but osteo means bone and clast means breaking down. So osteoclast, those are cells that break down bone tissue. Now the reason they would do that, we know that there's a ton of calcium inside of our bones. So if we've got low blood calcium, we're going to break down our bone tissue to release some of that calcium that we've got stored up. So that calcium that is released, it helps pull our blood calcium back up towards normal. All right, at the same time when we do that, we are going to break down our bone tissue, and that gives us too much phosphate inside of our bloodstream. We want our phosphate levels to stay normal. So we can get extra calcium, but that's going to also cause an increase in phosphate. So to counteract that, the last thing that parathyroid hormones do is it causes the renal tubules to conserve calcium, so that's also going to help our blood calcium stay high, but it increases the secretion of phosphate. So that causes increased phosphate excretion in our urine, and that helps balance out the fact that we're having too much phosphate in our bloodstream from when we broke down bone tissue. All right, so it's kind of a lot that's going on right there, but what this is saying is that we increase our calcium by absorbing more from our food, by breaking down bones and getting the calcium from there, and from keeping calcium inside of our kidneys. We don't excrete calcium through our urine. Now, one of the side effects of breaking it down from our bone tissue was that we release too much phosphate in the bloodstream. So to balance that out, we excrete more phosphate in our urine. So that balances everything out. All right, so that's it for part 2. We're going to look at calcium when we start back on part 3 in just a little bit more detail.